Hello, my name is Darren Kosinski. I'm a developer on the FireMonkey team at Embarcadero. Today I'd like to talk to you about some of the new things in the FireMonkey framework in Rad Studio XE3. We're calling this new version of FireMonkey FireMonkey 2. In this session, I want to talk about some updates we've made to the framework, some new features for layouts and multimedia, and some changes to the way FireMonkey handles bitmaps. There are a lot of new features in FireMonkey and also a lot of internal changes. One of the internal changes is what we're calling framework refinements. This affects properties, and it also affects the location of some types and functions. We have some new multimedia features, and one of the big architectural themes for FireMonkey 2 is to prepare the framework to handle more diverse platforms. You might have seen the mobile platform roadmap that was published on the developer network recently. That roadmap gives a good indication of where the framework is headed. It takes some preparation for the framework to support mobile platforms, and you can see in this release we're laying the groundwork for that. In this session, I'm going to talk about a couple areas where we did some work to support the new platforms. One is in layout control, and one is in graphics performance. So what are some of the framework refinements that we made? We went through all of the properties of every component in the framework to make sure that only the relevant properties would be published. We also made sure that properties are only published at the leaf nodes of the hierarchy, and the properties had appropriate default values. When a property is published on a Delphi class, it means that the value of the property can be streamed to the form file, and it also means that the property will appear in the object inspector at design time. So what we wanted to do is to make the components easier to design by making sure that the only things that show up in the object inspector are the properties that are applicable to the component. We also wanted to make sure that a component wasn't inheriting a lot of properties from base classes that were not really necessary. So that's why we made sure that we only publish properties at leaf nodes of the hierarchy. That also makes it easier to extend components because developers can then have the same advantage that we have, making sure that they're not inheriting unnecessary properties. What all of this does, it also makes forms faster both to save at design time and, more importantly, faster to load at runtime. So when a form is loaded and the runtime is reading the form file or the form resource, it has to create all of these properties and set all of the values. So to the extent that that can be minimized, it will speed up the creation of forms at runtime. So these changes help put the framework on a good footing to support the new components that will support future platforms. Another refinement that we made is we moved a lot of math functions into the RTL. When FireMonkey came into the Delphi universe, it brought with it a lot of floating point data types and functions to manipulate them, and also a bunch of math functions. And these have lived in the FireMonkey framework in Delphi XE2. And what we wanted to do is, since these data types and functions are not really specific to FireMonkey, we wanted to move them into the RTL so that they can be used by all kinds of Delphi applications. They could be used by VCL, they could be used by something that doesn't really use a framework. And so a lot of this non-framework specific functionality was moved out of FireMonkey and into mostly a couple units, system.types and system.math. And while we were taking a look at these types, we also wanted to modernize them a little bit. We wanted to make use of record constructors, class operators. And what this does is it makes the data types easier to use, it gives better encapsulation, and it reduces the symbols that are in the global namespace. Let me give you an example. Let's look at the T-vector type. In Delphi XE2, you can see that T-vector was just a simple data record storing 3 floating point values. There were also a whole bunch of utility functions that were for making a vector record and for manipulating it and doing vector math. There's actually a whole lot more functions than what's shown here, but this is just an example. And what we did in Delphi XE3 is we changed the record so that we now have record constructors in it, and we have class operators. You can see in the highlighted section that the basic data is still the same, but now we've added constructors, functions, and class operators to make it easier to use. The operators will make your code easier to understand and more concise, and it lets you chain math operations together more easily. So this is what we've done to refine and polish the framework in FireMonkey 2. Okay, next I'd like to talk to you about some of the new multimedia components that are in FireMonkey 2. We've developed a mechanism for using the native media player libraries of the operating system to render into a FireMonkey control. This gives us the best playback fidelity, the highest frame rate. And so on Windows, we support Windows Media, and on Mac OS X, we use QuickTime Player. And those native libraries render into this FireMonkey control for video playback and audio playback. And then we also have new components that let you capture audio and video and store the stream into a file. So these are the new components that we have. We have Team Media Player, which is a non-visual component that provides all of the control functions for playing back media, the ability to start, stop, etc. The Media Player control is a visual component, and it's primarily a placeholder on the form so that you can design other elements around the media player. And this control provides the rendering surface that the native graphics library will use for displaying the video. And then we have T-audio capture device and T-video capture device, and both of those provide the ability to capture audio and video and store it as a file. So I have a demo of the media playback that I'd like to show you. Let me switch over to my demo machine here. This is the FireMonkey Media Player HD sample that ships with Rad Studio XE3, and I wanted to talk through a couple of the components and the way it works to show you how easy it is to work with video in FireMonkey 2. The component that does all of the work is this non-visual component, Media Player 1. You see it has a file name property and not a whole lot else. Its primary use is in the functions for playing and stopping, and it also controls the native graphics library or native media library. Then we have this Media Player Control 1, which is the visual component. This component provides the rendering surface that the native playback library is going to use, and it also takes up the appropriate place on the form so that you can design your other elements around it. So you see in this case we have this media control, and then we have a toolbar with some buttons on it. We have load, pause, clear. We have a control for volume, and down here we have a track bar control for showing the progress as it plays the media. Let's take a look at the code. You'll see that the button clicks perform various actions using the media player. So when you choose the load button, for example, it comes to this open button click, and this will launch a file open dialog that you choose a file name, and then it assigns that file name onto the non-visual component, the media player. Then it looks to make sure that the media was able to load. When you set the file name, the non-visual library will initialize the non-visual component will initialize the native media library with the file name, try to load the file name, and it makes sure that the media was loaded successfully and that it's able to be used. It gets some information about the media, finds out what the size of it is, what the duration is, so that it can set that on the track bar component, and also set some information that we'll see on the form. and then it calls play. That's just the method of the T media player, which makes the playback start. The pause button will either start or stop the video, and again it does that by calling the start or stop and play methods of the media player non-visual control. The clear button will clear the video. So really the non-visual control is the one that does most of the work. So let's take a look at what the performance looks like. So let's run the application here, and we will load a file. I have a video here. This is a Windows media file. It's going to load it and it's going to play it. And let me turn down the volume here. You'll see that this is an HD video. It's 1280 by 720 pixels, but you get very good video quality, very good frame rate. Can pause the video. We can start the video back up. We can move around on the video, and this is all of this starting, stopping, changing the playback time. That's all done through the non-visual media player control. But you get a very good display because it's using the native media library for playback. And you can even resize it, and you still get very good performance. So that is the media player features of FireMonkey 2. Next, we have some new features that are useful today on desktop applications, and which will be even more useful in the future as FireMonkey moves on to new platforms. And this has to do with layout management. We now have anchors in FireMonkey. These are very similar to the anchors in VCL. And we have some new layouts. T layout we already had in FireMonkey, the FireMonkey 1 in Delphi XE2. T flow layout and T grid layout are two new layout managers that we've added in FireMonkey 2. The VCL-like anchors have been added to the FireMonkey T control. So just about every visual control, every HD or 2D visual control will have the anchors. It inherits them for free, basically. And we have two new layout managers, T flow layout, which you can kind of think of as like a word wrap for controls, and T grid layout, which does layout of grids. I have a demo of both of these, so let's go over to that. Okay, so let's go over to the demo machine, and this is just a new FireMonkey Forms application. There's nothing on it yet. What I'm going to do is drop a T layout onto it. Let's make it a little bit larger, and just put a button inside the layout. Okay, and let me move the button down here into the bottom right corner. And then let me show you what happens without the layouts. If I resize the layout, see the button is now kind of hanging outside of the layout. That's probably not really what you want to happen. If you have something in the bottom right corner, you probably want it to stay in the bottom right corner. So let's take a look at the anchors for the button. So by default, controls are anchored to the left and top. So we want this on the bottom right corner, so let me anchor it to the bottom and the right side instead. So now, if I resize the layout, you see that the button stays roughly in the bottom right. As the layout resizes, the button stays in the bottom right because that is what it's anchored to. The anchors are relative to the parent. So if I were to resize the form, you see that doesn't really have any impact on what the button does. But if I resize the layout, because the layout is the immediate parent of the button, the container for the button, that's what the anchors are relative to, so it stays positioned here. If you anchor on opposite sides, then what happens is the control will tend to stretch. So instead of bottom and right, if I were to instead do left and right, then if I were to stretch out the layout, you'll see the button will stretch out, and it maintains proportionally the same size, but since the layout got bigger, the button got bigger. And similarly, if I shrink it, the button will shrink. And if I resize, again, it's going to stay roughly where it's positioned, but it's also going to stretch because it's anchored to the left and the right. And this happens at runtime too. It's easy to see it in design time, but the same behavior happens at runtime as well. So now let's take a look at the new layout managers that are in FireMonkey 2. So here we have a form that has a couple different things on it. We have a flow layout which occupies the whole form. You'll see this is a type flow layout, and like I mentioned earlier, you can think of flow layout as being like a word wrap for components. Let me show you what happens if I resize the form here. So what the layout did is the layout holds two components. It holds a memo and it holds this other layout called right or bottom, which is a T layout control. So the flow layout has those two controls, and so what it's done is it has wrapped around the controls. There's no code that's making it change its positions or anything. This is all being done by the layout manager. So the form resizes and it relays the components out based on what will fit on the new form. So that's basically what the flow layout does. And like with anchors, this works at runtime as well as design time. It's kind of easy to see at design time. Now within this layout, we have this keypad, and you see this keypad is a T grid layout. And a grid layout basically ensures that a whole bunch of components fit into a grid. And what I'm going to do is resize this a little bit so that we can see things. And then let's look at the keypad. And you see the keypad has a whole bunch of buttons in it. And they're put into this grid layout. And if we resize the grid layout, you see that it will realign them on the grid based on how things will fit in the space that's available to it. Grid layout ensures that things are going to be all evenly spaced within the space that's available, whereas the flow layout is more like a word wrap. It just flows things to new lines. What I'm going to show you, well, let me go ahead and run the application, and we'll click this flip button. And you see everything just got laid out differently as the form switches to being vertically oriented as opposed to horizontal. If I click it again, see it changes back to horizontal orientation, and the components are laid out differently. And what I want to show you is, let's look at the code. I want to show you that there's really almost no code in this application. We have all the controls that you see on the form, and then we have this flip button click. And the only thing that the flip button click does is it changes the bounds or the size of the form. It basically swaps it from horizontal to vertical or vice versa. There's no code at all that is arranging these controls. It's all done by the layouts. So you can see that that's a very useful feature for running on different sizes of displays, with all of the different sizes of from netbooks to desktops. Having a layout like this, layout managers like this, make it a lot easier to design your form. And moving into mobile platforms, this is another area that's going to be very valuable. So those are the new layout managers, the T-Flow layout and the T-Grid layout, added to the layout managers of FireMonkey. The last thing that I wanted to talk about in this session is some performance enhancements that we have made to the FireMonkey's bitmap handling. This is another feature that is useful today in desktop applications and which will provide even more benefits in the future as FireMonkey moves onto platforms that don't have as much horsepower as a modern PC does. For bitmap optimization, in FireMonkey 1, bitmaps were always stored and rendered in FireMonkey's T-alpha color pixel format. And that pixel format doesn't necessarily match the pixel format of the underlying graphics context. So the bitmap data had to be converted often, and there's always a cost that takes a bit of time to do those conversions. In FireMonkey 2, we convert the bitmap data immediately into the native pixel format of the graphics context. This allows the graphics library to store the bitmap data in a native format. It allows it to store it on the GPU, and that gives the GPU faster access to it and allows it to be rendered more quickly. So this generally improves the bitmap performance of FireMonkey. One of the things that is being covered in another session is the bitmap styles that we have in FireMonkey 2. And so with some of the styles being very heavily bitmap based, it was important for us to have as optimal a bitmap rendering as we could. So that was one of the motivating factors behind this optimization. So while you do get faster bitmap performance, there have also been some changes to T-bitmap that may require a little bit of refactoring in your code. The main thing is that because the bitmap data is now stored on the GPU as quickly as possible, we don't have direct access to the pixels or scan lines through T-bitmap. There are functions available for mapping and unmapping the pixel data to a buffer, so you can still get to the pixel data, but it's a little bit different process than what was done in FireMonkey 1. So this wraps up the presentation for this session. You've seen some of the work that we've done on framework enhancements, cleaning up properties and making math and data functions more usable. You've seen the multimedia playback features, and we've talked about the audio and video capture components. You've seen the new layout management tools that we have with anchors and the T-flow layout and T-grid layout. And we've talked about the improved bitmap performance of FireMonkey. In the next session, I'll talk about some changes to the platform abstractions, the touch and gesture features, and new sensor components. That'll all be in part 2 of the What's New in FireMonkey presentations. So thanks for tuning in.
Darren here in the studio with me, and let me switch back to this thing just so we're reminded of the topic. And I have to figure out the right microphone. No, there's 4 of them here. Why don't you snap into that? You're on mic 1. Go ahead,
Okay.
Darren.
Hi, everyone.
And there's Darren. All right, so let's go through. There was one question I handled already. It was before you got to it, Darren, which was are T actions supported in FireMonkey 2 now?
They are supported. Actions is one of the big new features. It was, we actually did quite a bit with actions. There's some common logic and there's some framework specific logic. The common logic for actions we moved into the RTL, and so it's shared by both VCL and FireMonkey. And then there's some frameworks specific portions of it, and VCL has its portion and FireMonkey has its portion. And generally the actions should work pretty similar to the way they work in VCL.
Okay. Let's see. Does the media player in VCL for XZ3 also get these new capabilities? I think the media player for VCL is the same as it was. It's tied to Windows, right?
Right. It's tied to Windows. It heavily uses Windows Media Player, and that was not changed in this release.
Okay. But if you use the FireMonkey media player and media player control on Windows and Mac, it works like it does. It works great on both.
Right, yeah.
And then when we move to mobile, again, these components come along with FireMonkey. Right?
Exactly. They're part of the FireMonkey framework, and so they'll work on all of the platforms that FireMonkey moves onto. as long as the device can support it.
Yeah, and the way I found out some of this stuff is when I go look at the FireMonkey runtime library source code, you'll see if-defs for things like iOS or something called next gen. You won't have an implementation because there's no iOS. So when I see, like, I think it's fmx.media unit,
right?
fmx.media.pass, and then there's an fmx.media.win and an fmx.media.mac,
right?
And if you look in fmx.media.pass unit, you'll see if-defs for these things. You'll see an if-def iOS, but of course, since there's no iOS that we deliver in exe3, there's no unit source code that you would find there, right. But you would find that if you had exe3 and joined the field test for mobile, for example.
Right, yeah, those are sort of little hints sprinkled throughout the source code about some things that are coming up in future releases.
Yep. And then you said it right up front about, and I think you're going to cover more of this in part 2, about a lot of the work that was done in FireMonkey 2 that relates to additional platforms beyond just Windows and Mac, sensors, right. Devices, things of that kind.
Yeah, the next session goes heavily into some work we've done with the platform abstraction. That'll make it a whole lot easier to handle devices that don't have the same capabilities. And yeah, I'll talk about that quite a bit in the next session.
Now, I already forget if I... oh, no, let's go to this question first. How do I go about obtaining the metadata information from the media being played in the media player? Things like, is there MP3 tags, MP4 video names, etc.? Yeah, there's some of that can be obtained. Some of it is exposed through the component directly, and some of it you would have to do a platform-specific query. If you look in something like in a unit like fmx.platform or fmx.media.win, that's the Windows-specific implementation. And you can see the calls that we make to the Windows API to get information like that. And some is exposed to the component. Some we haven't exposed in the component at this time, but you can always get it by going directly to the underlying media library. Okay. Sorry, I'm trying to catch up on typing, which is not hard, which is not easy for me. Okay. Does the media player use the GPU or the CPU to do video processing? Generally, it'll use the GPU if it's possible. Okay. David, you're so slow in typing. Okay. How come the T media player control in FireMonkey 2 does not allow you to rotate it, scale it like other controls? Actually, you can resize the T media control. You can resize it. You cannot do some of the things that you can do with other FireMonkey controls, though. You cannot rotate it. You cannot make it as a surface on a 3D object. You can't apply effects to it. The reason for that has to do with some compromises that we made to get the best media playback. When we first started doing the media controls, we had looked at using the media player libraries behind the scene and grabbing bitmaps and rendering them using FireMonkey onto a surface. And that would give the ability to do all the fancy things that you want to do with a FireMonkey control. But the cost of that was a huge degradation in the frame rate and the playback fidelity. And we felt that for a media player control, the most critical thing was having high quality playback. So at least for this release, we made the decision to sacrifice some of the things that you could normally do with a FireMonkey control and instead give you the best quality media playback. This is an area that we continue to research, and
There may be more things that can be done in future versions with this. But for this initial release of the media controls, that's the design decision that we made with it.
Okay. Let's see. Okay. Is there going to be full bidirectional support? People want right to left in FireMonkey controls in the future?
Right. That is definitely an area that is under active development. So I would expect that in a future release at some point we will have full bidirectional support. And when we do have that support, it will be on all the platforms that FireMonkey runs on.
Okay. Okay. How do you compare the performance of bitmap handling, I guess, for styles and bitmaps and images or whatever between FireMonkey and FireMonkey 2? If you cannot directly process the pixels?
Well, yeah, that has to do with the changes we made to the bitmap. One of the things in FireMonkey 2 is we added the ability to have bitmap styles. So the style itself, instead of being all vector-based, you can have style elements that use bitmaps directly. And so it was very important with that change to have very high performance in bitmap rendering. And that was the motivation behind the rewrite of the bitmap types that we did. And we get better performance with this by using the native pixel format, doing the conversion only once very early in the process. And then what that allows is it lets the graphics library, whether it's DirectX on Windows or OpenGL on the Mac, it allows the graphics library to store the bitmap directly on the GPU, and then the GPU can do manipulations of it as required. So it gives much better rendering performance. If you need to manipulate the bitmap after it's been created, that's where there may be a little bit of a penalty, because you then have to retrieve the bitmap data off the GPU, do your manipulations, then it has to be reconverted into the native pixel format and pushed back onto the GPU. But for most of the uses of bitmaps within the framework, we don't do manipulations of it on a pixel level like that. Rather, we do we start with a bitmap, we want to store it on the GPU, and then we do transforms of it. And by storing it on the GPU, it lets the GPU do much more of the work for us.
And also, you could build custom shaders, right? You could build your own custom shaders to do all sorts of things in the GPU.
Exactly.
Yeah. Let's see. Can I think of FMT layout as similar to a T group box in VCL?
There's kind of a similarity there, I suppose. It's the basic T layout is a way to group controls all together. So in that regard, it is like a group box in VCL. Some of the things in the group box in VCL, you have like the borders and the titles, things like that are not quite the same with the T layout. But as far as it being a container that you can group components together and then move that container around so that everything moves at once, then yes, that's what a T layout is for.
And there's several types of layouts. Maybe you're going to cover layouts in part 2. I'm not sure.
Yeah, but actually I covered layouts a little bit in this. We have the 2 new layouts, the flow layout and the grid layout. And the plain T layout doesn't do any manipulation of the controls. It doesn't try and move them around. It just keeps them all together. But the flow layout and the grid layout, those both actively rearrange the controls based on the size of the container.
Okay. I can access video frames from a T video capture, but I can't access the frames from the FireMonkey Media Player. Is that true?
Off the top of my head, I'm not sure.
Okay. What corresponds to VCL frames in FireMonkey?
In FireMonkey 2, there really isn't a direct correlation with the frame.
Yeah.
You can do things with layouts, but with a layout, that's not really the same as a frame, because you can't save the layout separately and then put it on multiple forms like you can with a VCL frame. You can have subforms. You can have a form within a form. That's basically how the pop-ups work. So that's kind of close, but that's not really a design time element. That's something you'd have to create in code.
You can do inherited FireMonkey forms.
You can do inherited FireMonkey forms. But as far as all of the features of the frame, that's something that does not really exist yet in FireMonkey 2.
Okay. Yeah, someone here, Rick, is saying, I'm new to FireMonkey and trying to understand the whole notion of components can be composited with inside other components. So when a component has a button or two, those are actually buttons contained by the component, not just fake buttons being drawn by some component, right? Components can,
exactly.
You can embed anything in anything, basically. Well, almost anything.
Yeah, that's the kind of the fundamental basis of FireMonkey, is that almost any control can be a container, and almost any control can have children. And so you can compose very complex controls by having one control contain a bunch of others, and you get the full features of each control.
Yep. Yeah, it's pretty neat. Just drop a component down, drop another component down, drag it inside of another component, or select a component and add a component. It'll get childed, or
yes, it gets reparented.
They'll get parented right there in the container. In the container. There's a couple of questions here about if someone knows FireMonkey in EXE 2 and now they're moving to FireMonkey 3. What are some of the things, and you're covering some of the things that are new, but what are there things that people should watch out for that are different?
There is some stuff that's different. There's some things that have been moved around.
Different units, right?
Different units. Yeah. I talked in the session about some of the refactoring that we've done as far as properties, as far as some of the math types and functions. So there are a few things that have moved around. We tried wherever possible, and I think we got most of them. Whenever we took a property away, since the property was being unused, we made some custom property readers so that wouldn't give an error when you try and load an old project. It would just silently handle that the right way and update your form file. So most of the things should be pretty automatic. Probably the biggest area where there will be changes has to do with bitmaps. If you do heavy bitmap manipulation, made use of the pixel data and the scan lines, that's an area where you're going to find a lot of things have changed. And again, there you want to use the map and unmap mechanisms of the bitmap to get to the raw pixel data that you're looking for. That's probably the biggest area that we couldn't handle automatically. That would require some code updating.
Okay. Is there going to be a web browser in FireMonkey anytime soon?
Possibly.
Yeah.
That's something that I know has been requested a lot.
Yeah. I know on mobile devices, there's WebKit at every mobile device, so there's sort of a built-in browser on different platforms.
Yeah.
There's no single one runtime. You've got IE runtimes, Chrome runtimes,
right.
Firefox runtimes. You got different things on Mac and Windows.
Yeah.
There's no sort of reusable common browser platform, and then, of course, all the rendering engines for JavaScript, HTML, CSS, and so on.
Right, yeah. If you look at iOS is all heavily based on WebKit. Mac is heavily based on WebKit. On Windows, there is WebKit that's available, but it's not part of the standard Windows installation. So there are a number of pitfalls for doing a web browser control when we have a cross-platform environment. But I do know that it's probably the top requested component to add to FireMonkey, and those requests are not falling on deaf ears. I would say stay tuned.
I don't know if it's the top requested. The other requested is, what about Rich Edit?
Yeah. That
other top requested.
Those two are neck and neck, I think.
Yep.
Again, that's something I would say stay tuned.
Yep. Again, some people would say, well, which Rich Edit APIs do you want to support? Again, there's different ones.
Yeah.
Yeah.
Yeah, that's something that with when you work cross-platform, it adds a lot more complexity than when you're working in just Windows.
I think taking a step back, you said it sort of in some of the Q&A conversations and in your presentations, is one of the guiding lights of FireMonkey is making sure wherever we can to have that capability on all the platforms that FireMonkey runs on today and will run on in some reasonable future.
Exactly. For the components themselves, you should be able to design a form with any components that you want, and then that runs anywhere, provided that the hardware supports the functionality. And that's something that we'll talk about in the next session a little bit, is for some of the more esoteric things, where you really need hardware support for it, and this is particularly true with sensors. You may have a component, but that component needs to know if the device actually supports it or not. And that allows the component to work correctly if there's hardware support for it, and to essentially be inert on platforms where there is no support for it. So that's something that we'll talk about in the next session a little bit.
Okay. I think maybe we talked about some of this as it related to Bitmap. There's a question of, did you remove direct pixel scanline access for T-Bitmap throughout the VCL or only in FireMonkey? Sorry.
That was just in FireMonkey.
Yep.
The VCL bitmap remains the same.
Is there, this is probably my personal question as it relates to bitmaps on certain platforms or not. I remember in FireMonkey 1, I was trying to take a bitmap, for example, from the T-video capture interface, right, which was a certain type bitmap, and then I wanted to put that into a T-image VCL bitmap, and it said those two bitmaps weren't the same.
Right.
I guess I needed to do a bitmap conversion.
Yeah, that's still kind of the same. The format that FireMonkey saves bitmaps is T-alpha color. That's what the pixels are. And when you get something from video capture, the capture device is going to capture it in whatever its native pixel format is. But then when it's actually saved into a bitmap, it gets converted into T-alpha color.
Okay. So I could always convert it.
Yeah.
Yep. To native again. Okay. So it comes in as native, gets converted to T-alpha color, and then we just convert it back.
Right.
Okay. Then I can do that. Then I can use T-video capture with a VCL app.
There you go.
Okay. Because you can you're going to talk in the next session too about sensors and so on, and yeah, the low level. There's, I think the pattern, you can explain the pattern if I get it confused. There's like FMX dot something, VCL dot something,
right,
and then or Windows dot something, and then there's system dot something,
right,
as these fully qualified unit names. Maybe explain to everybody again, sort of the precedence or how things are built up.
Yeah, we introduced namespaces in Red Studio XE2, and so that it eliminates unit name conversions. And that was one of the big motivations for it, is when we brought FireMonkey into the platform. So FireMonkey has a forms unit, VCL has a forms unit. We wanted to make it really clear to somebody who's writing code, what form am I using? And so we introduced namespaces so that we can still call our classes T-form, we can call our unit form. And so we added the FMX prefix to FireMonkey, and we added the VCL prefix for VCL. That gives you an instant indicator of what framework it is that you're working with. And then for the RTL, we added the system prefix because that's not specific to a framework. It's common to the entire Delphi RTL system.
So that way, if there's a certain capability that FireMonkey would use, some of that was refactored when it was platform agnostic or framework agnostic. Those things you'll now find in system dot.
Exactly. Wherever it was possible to do so, we moved things that were not specific to FireMonkey. We moved those to the RTL so that they could be shared between FireMonkey and VCL.
So, for example, action lists. There's some parts of action lists that I think were, unless I'm getting this totally confused again, that were moved down into system, but then there are still VCL and VCL dot and FireMonkey dot action handling bits.
Exactly. There's parts of actions and action lists that did not depend on the framework at all. So rather than having two copies of the code, having to fix bugs in two different places, we wanted to have one common place for it. That way both frameworks can benefit from fixes and performance improvements that we do there.
Yep. And again, that's where if you take a look at the what's new in exe3, there's a section in the what's new as relates to FireMonkey and also refactorings that are done for things like what's new in actions and menus and other things where these pieces got refactored into some of these common units that could be shared. I think it's great and cool. It cleans everything up.
Yeah, exactly.
Yeah. Let's see. There's a question about migration. I'm going to defer the migration from VCL to FireMonkey. We have media converter. It doesn't convert everything. Mm-hmm. For some things where there aren't equivalent controls in FireMonkey, for example, if you're using the Quantum Grid by Developer Express, you need to go to Developer Express and say, hey, you want a FireMonkey version of that, or take a look at the TMS grid for FireMonkey, which has all sorts of additional capabilities beyond the T-grid and T-string grid that we provide in FireMonkey. So, again, converters can never do everything moving from VCL to FireMonkey, especially because of containership and other things.
Yeah, there's just some very fundamentally different concepts behind VCL and behind FireMonkey that makes it next to impossible for any kind of automated code converter to do the right thing.
I mean, if you have simple, straightforward controls, you have buttons, edits, list boxes, all these kinds of things. Media Converter will do it. There's a free version, there's an Embarcadero edition of Media Converter that is, if you have exe3, you go to the registered user download, you can download that Embarcadero edition and just throw it at your VCL forms for Delphi and C++ Builder. And it'll do some of the work for you and then go in. Ultimately, if you have very complex forms, I just suggest take a step back, look at FireMonkey and say, how can I build up a user interface using the FireMonkey way of doing things? Again,
exactly.
Media does a lot. It'll do live bindings. It'll do all sorts of things for you. It'll try to composite some things where it can and find equivalents so it can help you, especially if you have 5,000 forms or 500 forms, you can get a lot of work done. But ultimately, you want to go back to FireMonkey and say, oh, how can I do this the FireMonkey way?
Exactly.
Yep. Okay, we have a couple more minutes. The good thing is Darren's on the next session, so we'll just move right into part 2 versus people leaving and people coming in. Right. Let's see. Can you tell me where T.F in FireMonkey? Patrick, I don't quite understand the question. Something about T.F when you're in FireMonkey too. I mean, there's a T.F. I mean, it's there.
Yeah, T.F. That's the floating point point type, and that's in the RTL.
I forget where it is.
I forget where it was in exe2, but it's in the RTL now, so it can be shared by framework.
Yep. Okay. Future plan for creating more business-wise controls like autocomplete combo box. I mean, there's always things. Send those requests in. Send them to Marco Cantu now, and he can. He can build the business case for getting R&D to build all sorts of things.
Exactly. Put them in Quality Central as feature requests.
Yep.
we're always looking for new and interesting things to add to the framework, and it's good to know what developers really need.
Will you support in future versions of IFMX mouse service? We can talk about services in part 2.
Yeah.
So maybe I'll defer that one. CG warp mouse cursor position. Oh, okay. It's maybe this is something from the Macintosh side. It looks like NS point or something. Yeah.
Okay.
Okay. All right. Yeah, we'll do that. Okay. Is there a reason why T-style tag is not registered in the component palette? Okay.
Yeah, for a specific property like that, I'm not entirely sure. It was unregistered. But basically, if it was removed from the published section, we found that it was something that was not appropriate to be published anymore.
Mm-hmm. I mean, if it's public or if it's still in the class, you can write code
exactly
to get to it. I think there's some of the components. There's public properties.
Right.
Yeah. I think like in some of the effects, the center point of where the effect takes place or whatever aren't published. They don't show up in the object inspector, but they're still available.
Right.
Yep. Okay. Oh, and there's a question about what about Microsoft Surface controls? Well, when we get to the Microsoft Surface, Windows RT, all sorts of other new controls, you can already use Metropolis UI styles in FireMonkey 2 today for a lot of things. There's the ability to add speed. What are they called? Those buttons you can add inside of an edit box, for example, the password button, and you can composite all of those, the cancel button, the search button.
Yes. Yeah, that's in FireMonkey today.
Yeah, that's in FireMonkey 2 in EXE 3 today. So again, some of those new controls that are appearing in things like Microsoft Windows 8 and so on, you can already composite because you can composite controls inside of controls. And there's some specific things for certain styles already available inside of FireMonkey 2 today. Yeah. Do you want to, there's a question here about what Ahmed noticed that we have DirectX 10 support in FireMonkey 2 now. Anything to discuss about, is there any new additions, or it's just that it supports DirectX 10? And
it supports DirectX 10. That was part of the process when we were rewriting the bitmap logic. We looked at the benefits that DirectX 10 offered, the platforms that it supported, and realized that we could get some performance enhancements by supporting DirectX 10. And for older systems that don't support DirectX 10, we'd fall back to DirectX 9. So it's just part of staying on top of the platform and targeting the biggest range of platforms that we can.
Yep.